Hello everyone, my name is Surbhi Sharma. I am from Department of Computer Applications. So for today's session, my topic is Introduction to Context-Free Grammar. Before knowing about context-free grammar, we should have an idea about what is grammar. So generally, grammar is a foundation for any language like Hindi or English. Each and every language has a particular grammar through which we are able to make valid sentence in that particular language. So in computer applications also we are having grammar. Through the help of grammar, we are having certain rules through which we are able to make valid strings. And these valid strings can be recognized by a machine, right? So, in order to validate our string, we are having a grammar. So, how can we define a grammar? Grammar is basically defined with the help of four tuples. These tuples are VTPS. So, what is the meaning of VTPS? V stand for the set of non-terminals. Non-terminals, or we can also call them variables. As the name suggests, variables, they can be replaced by some another value, right? So a particular variable can be replaced by a variable or a terminal. What is T? T stands for the set of terminals. So our string is actually composed of terminals. For example, I have a string A, B, A, right? So what is A, B? These are terminals. So actual string is composed of the terminals. Next is capital P. P stands for set of productions. So in every grammar, we have certain rules. These rules are actually denoted with the help of productions. Productions actually relate non-terminals and terminals. Next is capital S, which stands for starting symbol, from which the strings in the grammar are derived. So whenever we have to derive a string, we have to start with a starting symbol, and usually we denote it with the capital S, right? So whenever we see this symbol capital S, we should know that it is a starting symbol. Or if there is some specification, some special requirement, then it will be mentioned in the grammar itself, right? So with the help of these four tuples VTPS, we will be defining the grammar. Now what is context free grammar? As per Chomsky hierarchy, we are having four categories of grammar, right? What are the four categories? Type 0, type 1, type 2, and type 3. Now, context-free grammar comes under type 2 category. Now, how can we identify that a grammar is context-free grammar or not? For that, we have to remember this form that I've written here. So, there will be only one variable on the left-hand side, right? It is written here that B belongs to the set capital V. So it will be a variable every time on left hand side, and on right hand side it can be a combination of variable and terminals. So it is written that X belongs to V union T closure. And if you're writing closure, that means epsilon is also included here. Now let us understand this with the help of this example. So this is a grammar which is context free. So we should first identify the four tuples VT, TS, right? So variables, what are the variables used in the grammar? Only one variable is there, which is capital S. What is the terminals which are used here? There is only one terminal, small a. So we can see the differentiation between variables and terminals here. Variables are written with the help of capital letters and terminals are written with the help of small letters, right? So now next is P. We have to identify a P. So P is the set of productions. So how many productions are given here? Two productions. This is the first production. This is the second production, right? And starting symbol is also given here. Okay. So now just see the grammar is CFG or not. So we can see on the left hand side there is only one variable, and on right hand side it is a V union T closure. So right, the rule is validating here. This is CFG. Now we have to see what kind of language it is generating, right? So we can see that whenever we will start with starting symbol here, we have a production S tends to AS, right? Now, what are the ways to replace this S? Either we can write AS or we can write epsilon. Okay, so let us again replace it with AS. Okay, and now let us replace it with epsilon. So, what is the string that we have obtained after doing this? A, right? So, it means we can generate any number of A with the help of this production. Beta A, beta double A, beta A, and so on, right? So all the number of A's can be generated with the help of this rule or this production. And we are clearly seeing here that there is also production S tends to epsilon. So there is a possibility that language also contain epsilon. So this is a language which is actually being generated here. So how can we denote this language? We can write it as A closure, because A closure means that any number of A can be generated and epsilon is also included here. Okay, so I think it's clear that how can we recognize CFG, and if a CFG is given, then how can we generate a language corresponding to that CFG. Now, derivation of CFG. With the help of production rules of grammar, strings can be derived. So if we are having our rules, we can derive the valid strings with the help of those rules. So derivation of a string starts with replacing starting symbol. So I've already discussed that whenever we will be generating some string, we will always start with the starting symbol. And with the help of production rules, we will replace it, and then we can generate our particular string. So let us take one example. Derive, this is a string which is given to us. We have to derive this string from given grammar production rules. So these are the two rules which are given here. It is the same rules that we have just discussed before, but here we have particularly given that we have to generate this string only, right? So we have to constrain ourselves that the string generated at the last should match with this. So a tree-like structure can be used here to solve this. So we will always start with symbol S. Now we know that we have two options only. Either we can replace it with AS or we can replace it with epsilon, right? So let's start with replacing it with AS, because how many A do we need in our strings? 4A we are required. So we will accordingly choose our production rule, so that at the end we will be left with 5A. So now again we have to replace this S. Again we will replace it with AS. Then again we will keep on doing it until we'll get 5A. Now we can see that we have already obtained 5A. Now we have to stop. Now how can we stop here? Now we should replace this S with epsilon, right? So the required string is obtained here. So this is a way to obtain a particular string from the given production rules, right? Let us discuss some more problems. Next, we have to give a CFG. We have to define a CFG for a given language. Now here we have a language for which we have to define a CFG, right? So CFG, that means we have to give the four tuples that we are discussing so far, BTPS, right? So variables, terminals. So what should be the terminals here, as it is clearly seen from the language that it is composed of two terminals, A and B. So in terminals there will be A and B. Now we have to mention the set of variables, our production set, and starting symbol will remain as capital S, right? Now we have to apply some logic through which we will get a string always in the form that the number of B will be twice the number of A. For example, if there is single A, then there will be 2B corresponding to that. If we are having 2A, then there should be 4B, right? So the number of B should be 2 times the number of A. So we have to apply the logic so that we can get the strings of this type, right? So let us try to make production rule. We'll start with starting symbol. So what will be the simplest string? We can add on here that n is either greater than or equal to 1. So at least a single A will be there. So this will be the simplest string here, right? Now, how can we create other strings? What should we do? Can we do this? What I've done here, I have placed this S in between A and double B. So what will happen here? Whenever I will be replacing this S, then how can I replace it with the help of this? It means whenever I am inserting one A, in addition to B will be inserted here. So every time my string will be in the form that the number of B will be twice of number of A. Okay. So this is the production with which we can get the strings of this type. So how many variables am I using here? I think only one variable, which is capital S. So in B, I have placed capital S. So I have defined my CFG here. All the four tuples are included here, right? So this is the solution for this particular problem, where a particular language was given to me and I have to define and I have to construct a CFG corresponding to that particular language. I hope this example is clear. Now let's move towards next question. Next question, it is asked that you have to construct a CFG of palindrome over input symbols. Now, what are palindromes? If I ask, so palindromes are the strings. We will understand it with one example. Suppose I am taking this string ABA. Okay. So if I read this string in reverse direction, then still it will be ABA. That means palindromes are those strings, the reverse of that string that should be equal to the actual string. For example, ABBA. So if I read this string in reverse direction, it will remain A, B, B, A, right? So reverse of this string is also the same of is same as the actual string. So now I have to construct a grammar that can create palindrome strings. So as I've told you earlier also that I have to mention the VTPS for the particular CFG. So starting symbol will remain as capital S. So basically, I should know the terminals. Terminals is given in the problem itself. So terminals will be A and B, right? Now I have to mention the variables that will be used, the production set, and the starting symbol is S only. So how can I solve this problem? What logic should I apply here? As you clearly see, that every time when I am writing a terminal, that should be repeated at the end of that string, right? So I should do this, or if the string is starting with B, the B should come at the end also, right? This is a possibility. Now, how can I replace this S? These are the two possibilities I've already written here. What can be the other possibilities? S can be replaced with a single B, the single A, or with epsilon also, right? So with the help of this rule, I can create any palindrome string. For example, the string that I considered here, ABA. Let us check. Am I able to create this? So I'm starting with starting symbol S. I will replace S with, because my string is starting with A, so I will choose the rule ASA. So among the given rules, we have to see that what is the appropriate rule for us as per the given string. So I have chosen ASA. Now again, what should I replace here? Because my string is ABA. So I have an option to replace S with B, right? So the required string I have obtained here, ABA. Now let us check for this one. Let's start with capital S. Now again my string is starting with A. So which rule should I choose? I should choose ASA. Again I have to replace this S. So how should I replace this? Because at the second position I'm seeing there is B. So I should replace this S with B S B, right? Now, have I obtained the required string? Yes, only one thing is left, that at the last I should replace this S with epsilon. Now I have obtained the required string here. Okay. So any kind of palindrome string can be generated with the help of this particular rule. Next problem, give the language defined by grammar. Now here I have given a grammar and I have to give the language that is generated by this particular grammar. Okay, so let us first check the what is given here. So we are given with the first we can see that it is the set of variables, because the capital letters, it means these are the variables, these are the terminals, these are the production set, and this is the starting symbol. Okay, so now we should check that what kind of strings are being generated here. So it will always start with capital S. So how can I replace capital S? This is the one way to replace, right? Or what is another way? It can be replaced with a single B also. Now, what is the way to replace this C? The C can be further substituted as A, C, A. Okay. So this C can be repeated again and again by ACA. So what are we observing here? That the number of A before C and the number of after C, it will remain same, right? So it is a kind of mediator here, which is separating the A coming before it and the A coming after it. And the number of these A will always be the same here, right? So what kind of a string will be generated here? Uh, this There's one correction. This B should be here. This B is here, not here. So whenever I want to stop this process, I will replace this C with small b. So the string generated by this is A B A A. Okay. So any number of A will come before B. The same number of A will come after B. Right. I hope it is clear that how can we solve the problems of CFG.